Hi, so for this example, we're going to go over converting coordinate systems between the polar coordinate system and the Cartesian coordinate system. So let's take a look at going from Cartesian to polar. So keeping in mind that Cartesian is our xy coordinate system, this -1, -3 would have x being -1 and y being negative square root of 3. So what I like to do is when I convert coordinate systems, I like to visualize where my point actually is at. So my point for this one would be, it looks like a quad 3 because my x and y are negative, and then labeling it, I go -1 in the x direction and then -√3 in the y direction. And then I'm going to draw the hypotenuse to my triangle because that is going to be very relevant for going to polar. So there's my right triangle. And thinking about what kind of triangle I have, because this is 1 and this is magnitude √3, this would be like a, let's see, 60-degree angle. So this would be a pi-thirds angle. And what would the length of the hypotenuse be? Well, we can think about our special triangles and arrive at the fact that it's 2. Or you could, if you didn't happen to know that, you could use your Pythagorean identity and say that it is the square root of 1 squared plus √3 squared, which is √4, which is 2. So that's our Pythagorean. Okay, when in doubt, I like to use the Pythagorean identity. Okay, so now we've got our R is 2. We just concluded that. And then we have to write the angle at which this is located. So the angle that it's located, it's a quad 3. So we're going to go pi-thirds beyond pi. So that would be, let's see, 4 pi-thirds. Okay. And as you guys hopefully remember, polar coordinates are not unique. So there are other ways that we could write this point, but I think this is perhaps the easiest way to write it. Okay, let's take a look at going the other direction now. So this time we're in polar. So our R would be 2, our theta would be pi-thirds, and I'm going to draw my picture about where this exactly is at. So my angle is pi-thirds and my radius is positive, which means you go to the pi-thirds line and you walk away from the origin 2 units. So pi-thirds is like here, and we're 2 units out. So that hypotenuse is 2. And then we clearly have a special triangle here, so I know that the side length opposite the 60-degree angle would be the √3, and the side length adjacent to my angle would be 1, because I know the 30, 60, 90 triangles by heart. If I wasn't sure about that, I could use some trig identities and figure it out. Like, for example, usually you might remember that x equals r cosine theta and y equals r sine theta. So that's one strategy for doing this. But like I said, I prefer a very visual geometric approach to these. So I already know what I need to know for writing this in terms of Cartesian coordinates, which is my x would be 1, my y would be √3. Nice. So hopefully this helped explain how to go back and forth between Cartesian and polar coordinates.